essentially the main objective for this software, was to create a software platform which can act as an interface for analyzing, designing, and editing glass. Some of the key features is the ability to import scan data from Quarryman, from a laser profiler or a drone, and data, your global deviation data. You have the ability to register, merge, consolidate multiple scans. You can remove any anomalies with cloud cleaning, cloud reducing filtering and sampling tools. And then, you can design and optimize drill patterns based on your burdens, your spacing, your hole depth, and your hole length. In a quick overview, this is kind of the software that we're working with.
So this is just the interface that we're opening up to with Blast Commander. So we're just going to create a new project here, giving it a name. Click Create. Some of the things that you would want to do first is just going through your project settings. So if you want to enter some general information through projects, we could bring in some control points. Right now, we'll just operate in the local grid, so that's not important. But that would just be through a CSV import, or you could even manually type in some control points as you so desire. But what we really want to do here for this demonstration is just making sure we're in the correct units. So for this data set, we're just going to be operating in feet. And from there, we're all set. So first off, we'd want to bring in our Quarryman surface. So under our surfacing tab, towards the right-hand side, we have our Quarryman import, our point editor, and our surface from points, which is the three buttons we'll be working with right now. So from the Quarryman import, we have some data coding templates that we could choose from. We could always select a new one. For the one we're running here, I'll just select our webinar. And just by opening this up, you could see the start, end codes, the colorization, and what they're defined as well as their feature type. So our feature type goes from line, target, color, and scan, depending on what each code represents. So with our data coding template selected, we're able to bring in our Quarryman FSC file. And when it loads in, we'll just get a summary here. Because we only have the one station, we'll only have the one station up above, but if we were to have multiple stations, they would appear along the top here, that we could switch in between them. If there was any information here that we would want to edit, whether the station height was entered incorrectly on the Quarryman, the target height for the colors were entered incorrectly, we could all edit that right now and click OK. If everything seems okay, then we could just close out automatically. Now, we do have the grid on right now. Just to make it a little bit easier, I'm just going to turn that off and recenter here. So here we just have our phrase scan. Couple of things we could do is just right off the bat is output our colors to a CSV. So we'll just name that as colors. If we were to have multiple stations, we could go through our station position calculation to orientate all our data so that they're linked to each other. And that's
just to weigh in quickly on this particular tool. This Blast Commander solves for the position of Quarryman using a network least errors calculation system taken from Carlson's surveying line, and it's fairly well automated. All you have to do is kind of input the bare minimum amount of data regarding, getting at least one position and one direction, which you can actually do simply from the control points, and it will align and solve for the system automatically, which of course is not necessary in this particular set.
No, because we're in a local grid, we only have the one station. We could leave everything as it is right now. I just wanted to touch briefly on that, and thank Julian for the quick explanation there. So with this, we've already outputted our colors. Really, we just want to create a surface from our points. But before that, we'll just quickly clean it up. Here, we'll while there are some point filtering options such as distance, signal strength, and elevation, what I'll just quickly do is delete by rectangle right now, just to take out some of these bottom points so that we can make a nice surface. We could also save our points here, so coming back to it later on, we wouldn't actually have to bring in our FSC file again. But next, we want to create our surface from our points. And so this is just based off of two settings, which is our detail and our trim. So if we went and tried to create the tin right now, we would actually get a notification in the bottom right that it's been filtered out just because the trim is high. So we'll just lower that down, say 7.8, and create our tin. So with that in place, we could actually go into our Scene Explorer on the left and just get rid of our points altogether now. We're also just going to quickly save this so that if you do come back into the project later on under surfaces, our save surface will be there. So next we want to bring in our bore track data. So we're going to go to our blast pattern layout tab. And Julian's going to touch base on a lot of these later on for the drill design or the hole design. But right now we're just focusing on bringing in our bore track data. So on the right here, we have design, surveyed, bore track. We're going to bring our colors back in as survey points. So we're just going to bring in that color CSV that I had earlier. Now, the reason why we export it first is that we could then open it in Excel or add more information to it. Under our column headers here, we have a number of different, I guess, titles that we could choose from. So if we had the bottom of our holes, we could bring those in as well as our surveyed survey. Wow, I'm blanking on the name here.
Yeah, so you can fill in extra fields with your dip or the azimuth or the length of your holes, and the system actually works basically by reusing information. So if you have a design hole and you know it's azimuth and dip, and you bring in a new collar, it'll reuse the design's azimuth and dip. So in this scenario, you're only importing the collars. But if you had more information than just the collars, for example, if you were using our fleet system, which can also give you the down hole, dip, and azimuth, then that would be available in this import dialog as well.
Yeah. So with this, we already have our headers correctly labeled. So we'll just click OK to bring our collars in. So now all we really want to do is attach our bore track data to it. So that would be through the bore track tab. So here we could bring in the older rotted bore track CDU files. We could bring in the newer Carlson bore track DRL files. We're going to work with some cable bore track data here. And rather than initiate a link to the CDU itself, we're just going to import this from a file. So by clicking next, we're seeing the holes in our scene as well as the holes from our bore track. Now, with them matching up perfectly, we could just click match by row and column, and we could also just do it manually if we so choose. The other thing we would want to do, especially in a local grid where our cable bore track's not oriented to the same grid system that the Quarryman is, we have our bore track alignment vector here. So by clicking this, we're brought back into our scene where we could replicate what baseline we shot with the cable bore track in the field. So say we went from hole 1 to hole 7 was our baseline. We're going to see, oh, I accidentally right-clicked. All right. We can see what our azimuth of that line is. If we accidentally click incorrectly, right-click would deselect it, which is what I did earlier. So when we have the correct line in place, all we have to do is hit enter to bring it back to our screen, and you'll see that our grid angle is calculated, as well as our magnetic angle. So once that's done, we'll just click finish, and we could see our bore track data relevant to our Quarryman data. Now these holes are already colorized. If we go under our pattern options, we'll see our colorization. If we go into our pattern layout, burden options, we'll just turn on our straight measurement at first. And if we select all of our holes, going into hole tools, we could turn on our distance line. So this is based off of the search azimuth. So right now they're all oriented towards 0. So rather than doing it individually, what we can do is under drill commands is calculate the search azimuth so that we're not playing with it ourselves. In here, so it finds its critical path. And then if we go back to our burden options, we could turn off that straight measurement to see the critical path of each of the holes. Now the colorization here is based off the burden tolerance that we've given it up above. We also have our measurement interval down below, so it's measuring every 3 feet down the face. Now to take that a step further, we do have our burden vision tab here. So rather than looking at how each of the holes is affecting the face, we could see how all the holes together are affecting the face. So we could actually add an inclusion line on this face, just subsampling the surface. When we're done selecting it, we'll hit enter just to complete that perimeter, and we're going to do, say, a 2x2 grid spacing of our surface. So we'll just turn off our tin just to make it a little clearer. But here we're seeing how all the holes are affecting that face. Now this becomes more useful, especially during the design portion that Julian will do later on. But basically from here, all we want to do is print out our burden report. So here, if we've done our burden vision, that will show up in our report, and we could also choose which holes we want to export to the report itself. So we're just going to click output.
So there's a bit of information that goes into this report. If you look on the right, you can see the numbered positions down hole. So that's actually taken from the perpendicular to the hole. So that's a very fine sampling of the whole wall, and then the actual line itself would then be the critical path. So you kind of get 2 different measurements concurrently. And on the report itself, you then end up with the burden vision result in the burden vision table on the right, which is colorized based on the burden and the burden tolerance items that Gordon filled in earlier.
So it'll just break it down page by page as each is a whole, and then as Julian mentioned, the burden vision tables on the right are burden calculations based off the distance line, and the parameters we gave it are on the left, and just some general information of the whole down below. Really, that's how we would process the Quarryman and bore track data at this point. So I'm going to hand it over to Julian, who will go over the design.
And so I'm just going to load up a blast that I have here, or a couple of surfaces for a copper mine. I believe it's out west in Utah. Forgot the name of it exactly. But what's interesting about it is that there were actually two surfaces that were generated, one of which is the topography surface, which you can see here. This one was actually made from a drone flight, and as you can see, it's a very detailed surface. So Blast Commander can handle with a lot of ease very large and extremely detailed tins. I believe the largest one we've actually run through here was about 120 megabytes for a tin, which would, it would give you probably your entire mine down to probably the half-foot accuracy for, 1 by 1 kilometer operation. Here they just have a fairly large part of a bench, and I believe the precision here was about a quarter or a third of a foot. So feel free to bring in just about any size tin into the software. It should be able to handle it just fine. Now, what's interesting about what they did is that they actually used our office software to create a very nice bottom here. This functionality is something that is being built into Blast Commander, so that you can generate these, highly detailed kind of desired outcome surfaces in the software. But for now, you can just feel free to make them in whichever surface design software you're currently using and bring them into software. So what we're essentially going to do is try to take this surface, maybe choose a part of it, maybe a little side of it, and we'll blow it up, because this entire cut right here is about 3 million cubic feet, and it's maybe a little bit too big for a single blast. So once you have both of your surfaces in, and you have played with the cube a little bit, what you would do is go into blast pattern layout, and you would select which is your top surface. Now, the top surface selection is important because it actually gets used for adjusting the collar positions. So if you have a surface and you choose to kind of drape your collar positions onto the surface, the elevation of the collars will be managed automatically as you move your holes around. Now, I'm just going to go with all of the default parameters, and I'm just going to lay out a very simple pattern. And then we'll start kind of going through all of the different options the software has from there. So I'm just going to turn off the floor here, just so we're only drawing on the surface. We're just going to choose a nice little piece here. Now you can see that everything drapes in real time, and it does so based on the camera angle. So if you want a very nice square line, you should actually probably switch to orthographic, and that way when you draw your blast boundary line, it very much is a perfect top-down projection. You can see how it drapes in real time. Now, we're going to lay this particular blast out front to back. You can actually lay them out back to front, which is totally fine, especially if you're doing something, for example, maybe there's some sort of back wall that you don't want to put any explosives on top of. So you'd be able to very easily draw your shot line along this blast line. But just to keep it simple for now, I'm not going to worry too much about that. And I'm just going to lay it out front to back. So I'm going to click here on face extents definition, and I'm just going to go around and I'm just going to kind of outline the crest of my blast. And then I'm just going to line this up a little bit, and I'm going to hit enter. Okay. So you can see how we have these green lines facing down in the direction that we want, and we have our face line following the crest. And what we can do is go into pattern geometry, and we can say, well, maybe we want 15-foot burdens, and we'll do the same thing on the collar spacing. And I won't turn on the fade dynamic layout yet. But what I will do is I will make all of the angles 0 for the holes. I'll make sure to set the collar elevations to use the grid elevation. So that way they'll be kind of matched to topography. And for the toe elevation, I'll get into the surface first, but for now, I'm just gonna do a depth of 40 feet. So with those defaults, and maybe the things we kind of played around with a little bit, I'm just gonna hit execute. Now, as you can see, it makes the holes and it lays them out. But you know, I'm kind of looking at this blast. I'm saying, well, that doesn't really go to the back. So maybe I'll add a few more rows. Hit execute pattern again. And now that I'm here, I'm going to maybe think, well, that doesn't really go to the bottom. And I do have this blast state floor surface here. So I'm going to set the toe elevation using that surface. And of course, you're free to set any sort of offset you want. But in this case, I'm just going to drill directly to the surface. And of course, that goes, you know, all of those drill holes go directly down to the surface. And when you edit them, any sort of edit that you do, it'll maintain those toe elevation parameters that you have set there. Now, as Gordon had mentioned before, it can be extremely useful to be able to see the measurement of the face to the holes, but there's also a lot of different ways to measure from the holes to the face. So what I'm going to do is I'm just going to turn on the first row, and I'm going to show you all the different ways that we have to measure to the wall. So I'm going to turn on distance lines, and I'm going to go here to burden options where you can find all of these settings. Now, one of the cool things about the software is that all of the measurements update in real time. You can see that as I change the dip, as I change the position of the collar, everything really updates in real time. And that makes it very easy for you to be able to lay out these holes, particularly the front row. So I'll give you, and it's not just these straight measurements that work that way. The critical path as well works that way. And we can do that perpendicular to the hole or parallel to the ground. And you can select as many holes as you want and have those work concurrently as well. And again, all of the measurements operate fairly well in real time. And that makes it very easy to kind of, you know, measure from, figure out where you want the holes relative to the face. Now, I do understand that it can be a little difficult or frustrating to try to measure all of these or lay them out when you're just seeing the measurement of the holes to the face. So instead of doing that, what I'm going to do here, I'm just going to turn off all the holes, and I'm going to use burden vision to just grab this free face here. So I'm going to do a quick and dirty job, 2 seconds there. Now, what's interesting about this inclusion line that you've drawn here is that you can also use it to kind of set the inside measurement area of your face. So if you're carrying out any sort of measurement for your holes, maybe if you were doing 3D, which would be measuring straight up here when I have it turned off, if you then go into burden options and you set this to 3D, you see how a lot of these measurements go straight up. Well, if you went into burden vision and you click this button of use as inclusion line, it would only be measuring to triangles that are actually inside of that inclusion line. So there's quite a bit of power for you to be able to, you know, declare kind of what areas of your surfaces you actually want the measurement to be done to. In this case, all I'm going to do is make a burden vision surface, and I'm going to make it with a spacing of 2 by 2. Now, the cool thing about this is if I go here into pattern layout, I can say, well, I can see that my collars are actually a little bit close to my surface. So what I'm going to do is I'm going to push those back to be 20 feet back, and I'm going to try executing this pattern again. And what it does is it moves all the holes back, it updates all of the visualization, and makes it very easy for you to then start playing around with the pattern defaults. Now I can see here that, okay, maybe my collars are a good distance away from my face, but I'm not actually happy with the distance to the actual down hole positions, or down the distance down hole to the face. So what I'm actually going to do here is I'm going to add some dip to these holes. Now I can see that this is roughly a, I don't know, here, let's check it. This is roughly a dip of 50 degrees. So I know that I can't actually drill a hole at 50 degrees. The drillers would come out and beat me. But I do know that this particular mine has done some drilling up to 30. So we sure as heck can't go up to 50, but maybe what we can do is go to 30 and we'll feather it a little bit. So not, to kind of get rid of that 30-degree angle. So I'm going to hit execute pattern here. You can see how this first row, if I click one of these holes and go to hole tools, you can see how the dip is 30 degrees. And then on the second row, it would be 15. And then by the third row, it's 0 degrees. Now, one of the things that I'm seeing here is, well, I think I'm going to have to set the tolerance a little higher just to make this a little prettier. But on this particular blast, you would have to really get very creative with the position of your collars and how you actually load this blast. And I'll get a little bit into the drill hole loading of it as well. One of the things that you can do as well is you have this collar Voronoi and bottom Voronoi diagrams. And you can actually use these to measure the volume associated to each hole. So under here, under info, here's the Voronoi volume associated to this hole, and then the Voronoi volume associated to B4. And again, this is calculated from the draped lines onto the surface. You can use this with the drill hole loading results and do your powder calculations on a hole by hole basis. That can actually be done at the reporting stage, but we're going to make sure to add some sort of visualization for that at this stage as well. But it's not currently in yet, but that way maybe it'll make it a little easier for you to lay out all of these holes. Now, we don't only have a way to feather the dips. We actually also have a way to make sure that all of these rows end up nicely aligned. You can see how our face kind of goes a little bit from the bottom left and then it goes up a little bit curved. And that actually gets disseminated back in our holes. Now in pattern geometry, that's happening because we have dynamic layout turned on. If we turned it off, you would get a very different looking pattern. You see how it's a straight line from the AB line. And of course, that has no consideration to the distance from the front row to the actual crest. Now, let's say you do want to have that consideration of the collar to the crest, but on top of that, you don't want your back rows to get all messed up. So what we can do is we can use this fade dynamic layout option and say, well, maybe we want our front row to follow the face, but by our third row, we want it to be completely straight. So you would set that, hit execute pattern, and you can see how these patterns kind of get updated instantly. And again, you see how the first row there is very curved. The second row has had that curve significantly dampened or averaged out. And by the third row, everything is completely straight. So that's very useful to kind of lay out your patterns. Now, there's a lot of other options you can do. You can add holes, for example, if you want. And you can add rows, and there's different ways of doing these things. I'm actually just going to delete this because I don't want that interrupting my beautiful Voronoi diagram, but it's very easy to edit the pattern after you've laid it out. So the concept is that you use the pattern layout tool and Bird and Vision to help you get within throwing distance, and then you use our very fleshed out hole editing system to then move the holes around. And of course you can you have collar measurements here, and if I go here under pattern options, I can set this label size, which should probably be about 3. And again, oops, I needed to deselect that. There we go. Again, all of these measurements update in real time. The Voronoi diagram updates in real time. The bird and vision surface updates in real time. All of the lines that measure from the hole also get updated in real time. So the concept of the software very much is all of the measurements always updated anytime you move anything. And the only way that that works is that we have a very advanced mathematics engine that allows us to actually update, tens of thousands of measurements in at 60 frames per second. So it's a very useful part of the software. Let's say you've laid out your pattern and you're extremely happy with it, and now all you're really interested in is putting some powder in it. So you can come here to drill hole loading tab. Now, this particular drill hole loading feature is something that is going to become general release in about 3 weeks. So there are still a bit of rough edges to it, but we opted to show it to you despite it not being fully complete. Now, the software still has a couple of features that are in development, so drill hole loading being one, the drill hole initiation being the other. And both of these are going to be in before the end of December of this year. So, and those will be included in the base version of the software. So very much Blast Commander is designed to take you through the entire design, loading, initiation, QA, QC, and any sort of machine control integration you need as well. So it's a one-stop shop package to do everything you need for the blast. Now, I've defined a few materials here, stemming, ANFO, and emulsion. And I'm just going to show you how these templates work. So this system was designed to be a through seam blasting system. So you can actually bring in information such as the elevation of water in the holes. If you make a surface for that, you can then modify your loading template based on the elevation of the water in the holes. Or say, for example, if you have a coal seam that you're trying not to blast to smithereens. I'm going to show an extremely simple case, and then I'm going to show you what a template would look like for a blast that has coal in it. Now, let's say all we're interested in doing is, setting some stemming and then filling the rest of it with ANFO. It couldn't be easier. This example hole settings, you can just fill out kind of a sample hole, something that you would have. So I've set it to be 45 feet long, and I'm going to go here into charging rules. And you can see here that this is the loading rules from topography to the drill bottom. So this would be the entire hole. I'm going to say that I want maybe 2 feet of stemming. Wait, these are 45-foot holes. 7 feet of stemming. And then I want the rest of the hole filled with ANFO. Now, it does the calculations of how much powder should actually be going in. And you can see that if the actual geometry of the hole changes, all of the different calculations actually get updated. And if I go ahead and take this very simple template and I then apply it using our applying charging templates system, which is conditional, so you would generate a number of different templates and apply it to the holes based on the type of the hole or the length of the hole or the row of the hole. And you click apply loading rules. What you can actually do is go into blast pattern layout again. I'm going to have to click design surface here. It's going to take a moment to recalculate everything. What I can actually do is color these holes by hole loading. So you can see that all of these holes have the 7 feet of stemming, and then the rest of the hole would then be loaded with powder. And all of these calculations are actually done real time. So let's say, for example, this hole was only 10 feet long. You can see how we still maintain those 7 feet of stemming, and then the rest of the hole is filled with powder. So what you can do is kind of generate one of these templates get an idea of how much powder is in these holes based on the templates that you've actually designed. And then you can move them around in real time. All of the loading calculations will be redone in real time. All of your burdens will be calculated in real time. Your volumes will be calculated in real time. So you'll be able to move everything around and quickly see how all of the math of your shot changes, again, in real time. We do have the ability to export our quick load report. There's a number of different PDF reports that you can make as well, which I won't get into all of them here. But essentially, if you need a specific format, please let us know, and we'd be happy to make that one of the outputs. I'm just going to very quickly show what a through seam one would look like, just so that you guys can get an idea of how the system would work. So I'm setting a coal top and a coal bottom here. And I'm going to say that the coal top is at a depth of 15. I'm going to say this hole is maybe 40 units long, minus 15. And then maybe the coal bottom is at minus 20. Excellent. And what I can actually do is come here and say, well, from topography to coal bottom, maybe I want, I don't know, 3 feet of stemming. And then I want the rest of that distance to be filled with ANFO, right? Now, I don't want the coal blasted to smithereens, right? So maybe I can say, well, 2 feet before you actually reach the coal, please stop blasting. And then for the actual length of the coal, I want stemming in there as well. And I also don't want any powder within 2 feet of the bottom of that coal. And I do that using the standoff function here. And what I can then do here in the coal bottom, maybe everything under the bottom of the coal, let's just say it's going to be emulsion, just to have something slightly different. And again, it would be variable. And you can see how the coal itself doesn't get loaded, and it gives that kind of padding of unloaded material or unexplosive material to the coal. The sky's the limit on this feature, simply because you can use any sort of surface. Maybe if your driller went through some sort of surface that you didn't want the driller going through, you can make sure to set a standoff of 2 feet to that bottom. That way you'll be able to put stemming or on the boot leg of the hole. The other thing that actually is available here is the concept of minimum thickness. So let's say we only wanted to deal with these coal seams if they were a minimum of 10 feet thick. Since this one's only 5 feet thick, it actually gets completely ignored. But let's say if it was minus 26, once it actually is thicker than 10 feet, then the software will not pinch it out. So there's a lot of functionality here on the drill hole loading. And of course, you can assign initiators to the powder here as well. Well, you probably wouldn't put an initiator in your stemming, but you would put an initiator in the emulsion. You can say how many initiators you want, where in the powder you want the initiators to be, and you can have multiple initiators on each hole. And there's of course going to be initiation functionality that's then going to link up with these defined initiators to allow you to then time your blast. So it's very much a fully featured blasting solution. It's still in its initial release, so we're still kind of on version 1. But we're also working on some UI improvements, making things more responsive and look better. We're also working on internationalization, so the software will be available, I believe it's in 14 different languages. So very much Blast Commander is fully featured, well supported, and it's built on a very modern platform and looks good, and it's easy to use.